Year 1, T1, T2 workshop. My name is Alberto Colmenero, and I'm a task leader for Year 1, Task 1 in the GA3 project. And the reason why we are a bit late today is because there's a huge traffic jam, and actually Tony, which is the first presenter, he's stuck in the traffic jam. So we are going to start with Victor Oliver instead. So this is the agenda for today, and also I'm going to show you the agenda for tomorrow. So we have actually a very long day ahead with many presentations, but many very interesting, I think. So the first one should have been Tony, but if he's some time, we will start with him, but I think he will be a bit late. So Victor Oliver from Janet will do a presentation about Ethernet OEM. Then Tony will do his presentation. Then we will have a coffee break. I'm going to talk maybe from here so I can see everybody. And then we will have Ethernet or MPLS and an MPLS TP presentation by Marcin and myself. Then a PVT presentation about Victor Oliver from Janet. From Blackman from Nordunet will present about next generation routed transport networks. This is a study that has been done also under Year 1 Task 1. Then we will have a break for lunch around 12:30. And then we have presentations from Lieven Lebro from Alcatel-Lucent, Samuel Perry from Siena, and Chris Liu from Infinera. Then we will have another coffee break around 3 o'clock. And there we will, you will get a small questionnaire where you just need to fill out what is your profile. Because for tomorrow's user case workshop, we're gonna divide you in groups. So we need to know if you are more of a level 1 guy or level 2 or level 3 guy. So, or all of them. So you just need to fill out with your name and your profile. Then we will have presentations from Anna Manolova from DTU about OTN and control plane. Asmus Lund from Nordunet will present about APIs. And finally, Jan Verdil from CESNET will present about photonic services. And then we will make a small summary, and we will have dinner 7 o'clock. That's for today. So tomorrow's agenda, we start 9 o'clock with a presentation from Herwig Ressing from DTU about time-sensitive transport. Then we will have a presentation about OpenFlow from Johan Tours from Nordunet. And then we will have our user case workshop. This will start at 10 o'clock and it will go until lunch. After that, this part of the workshop will finish, and then we will start the Terrain and Network Architect workshop that will run until Thursday. So some of you, I guess, you register for both of them, so you will get the agenda for that one tomorrow. The workshop will be a video stream and can be followed in that link. And if you like to tweet, you can also do it in that. GM3 Year 1 WS. And some practical information. So coffee and lunch will be served here because we are a lot of people, so just to avoid everybody going into the office area. So will be served here. Dinner today will be at Vesterbro Brødhus. And I think you will get, I don't know if you have the address in the agenda, otherwise you will get it later. So, and as I mentioned it before, will be served at 7 o'clock. If you need to print out your boarding passes for tomorrow, you can mail it to reception. And yeah, restrooms are down there, past the reception, to the left. If you need to connect to the internet, Nordunet guest is the access point, and the password is Rasmatas with a capital R. Yeah, and smoking, I've been told please don't use this terrace. There's another one in the other side of the building, and if you could use that one, would be great. And I think that's it. And since Tony is not here, I think we start with Victor. Any questions with regards to the agenda or?
Yes.
Okay. So good morning. I'm Victor Oliver from Janet. Worked for day1 task 1, carrier grade transport or future transport, I think. So my presentation, first presentation, is about Ethernet OEM trials which day1 task 1 carried out. And as you know, OEM stands for operation, administration, and maintenance. It's not something which does the main job, transferring packets between endpoints. But it's quite important topic which is pivotal for Ethernet to become carrier Ethernet, because OEM functionalities like a nervous system of human body, and without OEM functionality, no big system can work properly for a long time. So we realized that it's quite important strand, and we paid much attention at this. So I highlight some major standards in this area, and then highlight several trials which we carried out. So first of all, Ethernet connection which we would like to monitor and troubleshoot if necessary. So normally in academic environment, it's a multi-domain connection with Ethernet UNI. So customers see this connection as a pure Ethernet connection. Yeah, but in between can be several, as usual, several domains, campuses, regional network providers, core, national core networks, and each segment can have a different nature. For example, pure Ethernet, which is quite rare, or Ethernet over MPLS, or Ethernet over transport, where transport is any layer 0, layer 1 transport like SDH, OTN, and so on and so on. And actually we've got a lot of such Ethernet currently connections or services. JAN Plus, Janet Light Pass. I'm pretty sure other NRANs have such services with different names. And not only end-to-end user services, but as well inter-router connections now can be carrier Ethernet. And we can build these carrier Ethernet circuits on their own by our own means, I mean our network means, or we can buy such connections from third-party commercial provider. And generally, demand for such connections with dedicated capacity and the good performance, not very high in academic community, but probably we will expect more demand in future because of several factors like cloud-based services, high-definition video conferencing, and so on and so on. Now, what's the problem with Ethernet? So as you know, Ethernet has been a purely local area technology and without no OEM functionality at all. Ethernet is the cheapest transport technology, and for a long time it was quite acceptable. But not now, when we would like to use Ethernet as a carrier grade transport. And having this Ethernet connection, it's quite different from what we have from IP network. We can't use, well, we couldn't use until some time such useful tools like IP ping or IP trace route on the layer 2. Well, we can use, for example, OEM functionality of segments if they support MPLS or SDH or OTN, but it's just for tunnels, not for each separate connection within a tunnel. So good news that Ethernet OEM standards functionality, it's been in development since, well, development maybe earlier, 2004, 2005, but standards, major standards were approved in 2007, 2008, and currently it's implemented in all major equipment. Well, bad news, at least the bad news at, well, 2 years ago, well, that we, Janet, and other NRNs didn't have enough experience to implement it in practice for production services. That's why we carried out several trials. But first, let's overview standards in this area. So we see three quite obvious areas of emergent and emerged Ethernet OEM standards. According to the normal cycle of every NOC works. So first we should, after provisioning an Ethernet end-to-end service, we should be sure that we provisioned what our customer wanted. So we should check whether capacity is there, because Ethernet, it's not SDH, where capacity by design, well, in theory should be like we expected. Ethernet, it's a packet-based service with uncertain capacity. So committed information rate, excess information rate, we should check whether it's there for customer traffic and with expected performance. So it's the first step, service assurance standards area. Then, when we made sure that service is as expected, so we should provide it with permanent monitoring of a service. Well, especially if we provide quite strict SLA to our customers. So service is up and availability is 99 point something, and the performance is good if we guarantee performance, I mean delays, packet delays, and so on. So it's permanent monitoring, and preferably with some visualization tools, so customer and the network provider can see what's going on with this service, with this particular service. And then, if we have a problem or customer reports a problem, we should have some tools for service troubleshooting. And of course, it's a loop. So after solving the problem, we should make sure that service again conforms the SLA. So these three areas of standard. And fortunately, we have good standards approved and well-known, widespread for all these three areas. So first area, service assurance, several sub-areas. First, service definitions, very important, mostly from Mitra Ethernet Forum 10.2. Topology of service, for example, point-to-point, point-to-point, multi-point, multi-point to multi-point. Bandwidth profile, committed information rate, excess information rate, and quality of service. Yeah, it's very important because definitions could be different, and this is common denominator for all providers. Second special area, service performance standards, and there are two from Mitra Ethernet Forum and the ITU-T. And of course, when we have these standards which define how service should behave, so we should have something to verify or to make to do this procedure service assurance. And it's quite relatively new standard from ITUT. Y.1564 is a net service activation test methodology. Here gives us this background. Generally, it defines a simple, quite fast, but disruptive procedure, on-demand procedure, which generates traffic by step up to committed information rate, and at the same time measures performance delay, delays, delay variations, and availability. Then up to peak information rate, which is excess information rate plus committed information rate. It's a yellow area without any performance guarantees. And then if we police, or if we provide the police this service, it's a red zone higher than peak information rate, where all packets which exceed this rate should be dropped. And we've got several currently implementations in testers of this procedure, which is quite good because generally for Ethernet services it replaces IP-centric RFC 2544. You can use RFC 2544. It's quite good specification and it gives you a lot of information. But this is fast, simple, and it gives you minimum but necessary minimum of information, especially for Ethernet.
Excuse me, how long does that test take?
Well, for example, tests I did 1, 2, 3 minutes, something. It's up to you. Yeah, but generally it's not hours. Sometimes RFC 2544 requires hours.
But it is disruptive at that point.
Yes, because it's ramp up traffic up to the maximum. Okay, about our test. So for service assurance, we've done currently only local test within JNet test bed, and we are planning to do something wide area, at least between JNet and Nodinet, because we have a tester which supports Y.1564 and Nodinet. They have the tester from X4, maybe some other partners. So we did some local tests and we discovered that everything works fine, but interesting fact we came across. Initially we thought it's a new tester, just bug, because when we deliberately configured policy level in the box lower than expected, so our tester expected this one and a real station was like this, policing. So policing started earlier, not at this level but at this. So a lot of packets were dropped higher than this completely, so 100% loss. But we were quite surprised when our tester showed that everything is okay. All tests pass. Well, so we talked to a vendor, and at the end of the day we realized that it's not a tester problem, it's a standard problem, because this area is a yellow area, as you remember. It's unspecified performance, and the standard doesn't differentiate complete packet loss, red area, and yellow packet loss, which can be 10%, 15%, which is not good, we think. So we talked to a vendor. Well, they said that it's not possible to change the standard. It's ratified and so on, ITUT standard. But if you wish, we can do some amendments to our equipment, and you can specify some, for example, packet loss level to differentiate this yellow and the red zone. It's quite interesting. So, but it's for the further investigation. Now, service monitoring. So we've got service, everything is okay. So we need to do some day-to-day monitoring. There are two standards in this area from IEEE and ITUT. They're quite similar. This is first, it's a little bit later. And generally they define some hierarchy of heartbeat sessions between endpoints or intermediate points, which are called map monitoring endpoints, monitoring or maintenance. Sorry, maintenance. And so generally, different bodies, different providers, different operators, and users can monitor the same service, the same VLAN service, for example, VLAN 102. The same, but more or less independently. Heartbeat sessions independent, and they don't see each other because higher levels transparently pass by lower levels. It is quite useful. You can establish quite flexible system of this monitoring sessions. And ITUT Y.1731 standard generally specifies the same plus performance monitoring, delay, loss, and throughput measurements. Well, troubleshooting, same standards, CFM from IEEE defines a link trace, analogy of IP trace route, loopback, analogy of IP ping, and some signals which more or less similar to SDH, which indicates some problem. It's a richer standard in terms of troubleshooting functionality. So about service monitoring trials. We did 2 trials, or more precisely, we finished 1 trial and the second trial is ongoing at the moment. So first trial happened a year ago, 2011. 5 enrons participated. We established 5 wide area Ethernet connections. We used some small Y.1731 agent boxes from Overture and some software called Portal from a company called Cyan Optics to store monitoring data and visualize them. Well, we did some tests and we had some positive results, but we managed to do it only for single segment connection, just without hierarchy, just end-to-end monitoring. Well, because of shortage of time, resources, and so on. So, seeing some positive results, promising to convert it into something production. So we combined JRA1 task 1 efforts and resources with JRA2 task 3, which is about persona monitoring, and established a second trial for year 4, which started well, sometime in May, I think, more realistically 2012, and should be finished by March 2013. First trial, as I said, 5 enrons. It will be more participants because of Essex University represented, and Janet as a head office. And so we put these monitoring boxes, small boxes, gray ones, in each test bed, establish red maps, end-to-end maps. One connection, for one connection, Janet Lumen House to Essex University, we established 2 hierarchy between endpoints and provider level. So it was one computer served as a collector, which collected all monitoring data from these gray boxes and put everything into the cloud service, which I said called Sci Portal, and generates web service, so everybody with a proper credentials could see what's going on. For agent options, generally we chose a dedicated extra network switch as a source of OM data. Well, there are pros and cons for this option. Well, pros, it's quite, it makes your monitoring uniform, the same boxes for every domain. Quite rich and proven OEM functionality. There are cons, extra boxes, overheads, and generally it's mostly for end-to-end monitoring, because you can't put a box in between some big routers. Well, it's not viable solution. There is another option to use OEM capability of existing network boxes, routers, OTN switches with Ethernet functionality, for example, so on MPLS, for example, with Ethernet functionality. It's good, but it makes your environment quite cumbersome because every vendor implemented a little bit in their own way, Cisco, Juniper, and so on, so on. Yeah, but it's good to monitor not only end-to-end services, but some intermediate segments as well. And the third option you can use mostly it's as a replacement of these boxes. Some software OEM agent, like for example, a software called .1 AG utilities or utils, yes, utils, yeah, and developed by Sarah and Ronald van der Poel. So all questions to Ronald if you have them. It's also a good solution, quite cheap. It's a software platform, well, but it has also some limitations because it's a software solution, and currently there is some functionality limitation, for example, on the maps, and of course performance depends on the performance of your platform server.
Excuse me, in your first option, the network, this extra switches, are you including in that category, I know in data centers they have taps for legal intercept reasons, and these taps range from just a simple copying of data right through to deep packet inspection. Would you include that kind of box in the first?
That could be, but for example, the box we used, it's like this. So it's a very simple, small box with one management port and two ports, two pairs of ports for data, copper and SFP or XFP. And yeah, you could treat it like a taps because, yeah, but generally it's a cut-through box. Yeah, and with web GUI and quite rich OEM functionality. So we use this box as a source, like a reference source of OEM data. We had some positive results. So we monitored 5 connections over 6 months, and generally they properly show the state of the service, active or non-active, up or down. It's a compact form or more detailed form. You can see how CCM's messages you transmitted, how many you received, with some error signal maybe, so on and so on. We use these boxes for performance monitoring as well, for delay and packet loss. Also generally they behaved well, so showed for example between Copenhagen and Janet office in DITCAT. So two-way delay 23 milliseconds, quite stable. One-way delay 12 one direction. The same for between Poznan and Prague. But we experienced some problems with one-way delay, which is the most challenging measurement because it needs tight synchronization between endpoints. But I'll tell about it a bit later. First about SciPortal, because without this software it's quite tricky to do day-to-day monitoring because you don't know, or maybe you just forget what happened yesterday and before yesterday. So this is good system with a web interface, a web GUI, which shows on the Google map these connections in red if something goes beyond the CLA limits, like delay or status up and down, and black lines is everything is okay. And you can click in on a particular connection. You can see more detailed information, historical data with sliding window, the same historical data but shorter window, some information about each endpoint, and so on and so on. Quite good, with a possibility to do reports, monthly, weekly reports, and so on. And now, using this SciPortal, we discovered two strange cases of performance monitoring with ISG, the small boxes. First was a strange shape of two-way delays between Janet and Essex University. So there was no reason for this shape, which peaks reached about 1 second, which is incredible for loaded link from something normal to these peaks, and this period was about 2 days. Quite strange. So we started capturing traffic, and at the end of the day discovered that the small Sienna box was guilty. Generally, it was our only monitoring service with 2 levels of hierarchy. Endpoints level 5 and some intermediate points between Sienna 311V small boxes switches and extreme 12K belong to Essex University. So we started capturing traffic here and found the guilty box. It was small Sienna box, this map, which time stamped foreign packets of yellow session, which in theory this map had to pass it transparently without any intervening, but it put its own timestamp, which confused, of course, this box. So we didn't investigate it further, just realized it something, it's some bug in the implementation, which generally we should be aware of such situations. Another one, also strange, belonged not to Sienna box but to ISG themselves. So we found out that in some cases these boxes ISG couldn't measure one-way delay at all. You see, dashes here, so no data at all. At the same time, there was a proprietary protocol. These boxes support also proprietary protocol for measuring delays. And proprietary protocol works well. It's a data from proprietary protocol. This is data from a standard CFM. So we talked to a vendor, and their explanation was, so the synchronization was poor. Well, but it's a bit strange, because if a proprietary protocol can measure it, why a standard protocol can't? So it's something for the further investigation as well.
Is that an Ipanema protocol?
Sorry?
Is that Ipanema, the proprietary one?
It's proprietary called PAA, something like Performance Assurance Agent or something like this. It's quite similar to CFM, but it was implemented before CFM became a standard. So first trial conclusions. So generally we think that Ethernet OEM functionality implemented in the carrier grade boxes currently mature enough to use it in the production environment. Second, use of dedicated Ethernet demarcation boxes between customer and the provider. It's quite a good idea. Maybe not all customers need it, but on demand we can have some mobile boxes to put it when something goes wrong. Well, and the third, our main conclusion is that such systems like side portal, it's quite important, and we need them. And because it was, well, this trial, we felt that it wasn't enough to convert it in something, recommendations for the production service, so we established a second year for trial, which is currently ongoing, and with the following objectives. First, we wanted to carry on the previous trial, but extend it to multi-segment connection with real hierarchical monitoring, not 2 levels more. Pay more attention at troubleshooting, and use not only third-party boxes as agents, but also use CFM functionality of existing equipment, Cisco, Juniper, Extreme, what we have, Alcatel, Brocade. And the second part of objectives, they belong to GRA 2 task 3 persona. So people from persona team want to add Ethernet OEM functionality to the existing Persona software. So the year 4 testbed looks a little bit similar, but a little bit more sophisticated. Currently we use two types of connections. One is through Node.NET Core, MPLS Core. It's a virtual connections point-to-point, and one multi-point to multi-point. It's something new for this second trial, multi-point to multi-point. And the direct connections between some NRANs like Chestnut, PSNC, Chestnut to SoftNet. So we'd like to have multi-segment connections here and use not only these boxes, which we also using at the moment, but some main equipment in partners testbeds. And generally, what we are building now, we are in the middle of this job. It's a multi-segment connections using at least like here 4 domains. One customer domain, it's one box, for example, represented by ISG plus some end host. First operator domain, it's in this case it's example Janet Node.NET connection. 3 CNF5305 boxes, and it's one operator. Another domain, it's Node.NET testbed, Alcatel-Lucent 1850 boxes, and again customer would be campus domain. And as you see, 1, 2, 3, 4. Yeah, I would like to establish more levels, hierarchical levels. Why? Because I would like to be able to locate any fault, whatever it happens. For example, if fault happens between this and this box, we will have some information from a top level customer session, monitoring session, yeah, because it impacts this session. And this session also will go down, so we will be able to understand that something happens between this and this. And if something happens further, for example here, again, well, customer connection also always indicates that something went wrong, but to be more precise, we should use this information from this session. First, this session will go down heartbeat session, and if we use trace route, Ethernet trace route messages, and intermediate monitoring points, MIPS, so we will be able to understand that something went wrong between this MIP and this MIP. So this hierarchy levels, the system of hierarchy levels could be different. So a test should include first evaluation, what system of hierarchical levels can we recommend to to NRANs. And not only for shared levels like the previous picture showed. Shared levels mean that VLAN ID is the same for all domains, and all domains monitor the same service. Could be different situation, independent levels when, for example, some providers, operators use Q&Q encapsulation, and it's independent. Generally, it's completely independent monitoring for this. This could be two different hierarchical systems for this, and independent hierarchical system of monitoring for this. And another way, task how to visualize this information, because currently for hierarchical monitoring we have two different types of users, NOC engineers and end users. So how to present this information? Yeah, I'm finishing. Well, and so we should be able to emulate different type of failures, and this is our test plan for this year. So here it's a team from JRA1 task 1 and JRA2 task 3, and generally I finished. Thank you very much for your attention. Any questions?
Thank you, Victor. So any questions for Victor Oliver about Ethernet OEM? No? So I have one question for you. So I mean it's a bit early because we haven't finished the test for this part of the project. But with the experience we gained until now, do you think it will be possible to use Ethernet OEM in a multi-domain environment like NREN?
Yeah, I think so, but not necessarily we will be able to allocate the fault up to a particular box in some cases, but definitely up to some particular domain. Because if it's Ethernet over MPLS, for example, domain with MPLS tunnels, so Ethernet monitoring can't go deep in this hierarchy of encapsulation. So we will be able to monitor only outer VLAN ID, but not something inside. For this, we need to apply MPLS OEM functions, or if it's Ethernet over transport, so we should use SDH OEM or OTN. Yeah, but up to one domain, I think it's quite realistic.
Yeah, thank you, Victor. So yeah, we're going to shuffle a little bit the agenda. So now, Tony, you do the intro now.
Hello everyone, and sorry for the delay. Apologies very much, but I guess Alberto told you why. Hopefully.
Because you slept.
Yeah, I slept. I slept. That's right. But you also came in late. Yeah. Good. Let me see what we can do. Okay. I think it works. Could you just briefly catch up on what you already have said before I'm repeating something?
No, but we haven't said so much about the purpose of the workshop.
Okay.
Why we're here, so I was waiting.
You were waiting for me to start. Okay.
So we only went through the agenda.
You only went through the agenda. Okay. Yes, I will start and thank you everyone for coming here today. I guess Alberto already said that. I'm going to, in principle, start this workshop and kick this workshop off. And I'm glad that Victor could take over for a couple of minutes with his nice presentation. What I'm going to tell you about today is Gen 3 day1 future network, task 1 and task 2. I'll skip task 3 and task 4. Task 3 is federated network architecture, and task number 4 is about virtualization, current and potential use of virtualization. It's a little bit out of scope for this workshop, so the reason why is that I'm focusing only on task 1 and task 2, which is the task that's led by Alberto. I guess you have perhaps mentioned something about it? No? No? I'll come back to that. And the other task is about photonic matters, and that's led by Lars Langebjørn, sitting next to Alberto. Before I start, well, my name is Tony Breach. I work for Nordunet as Nordunet's research officer. I'm heading this joint research activity as activity leader, and I'm also going to head I'll not call it the successor of that, but in the next term when we're rolling into what's being called SHAN+, it's called also day1, but now it's about network architectures for Horizon 2020. So what I will do today is I will present task 1 and 2, what they have been doing the last couple of years, and then I will briefly catch up on the things that are going to happen in the next term under the SHAN+ scenario. The reason why we have a sample for this workshop is that especially these two tasks, task 1 and task 2, I'll come back to the naming later on, have been working the last 3 years where they have studied a lot of different technologies, reaching from the lowest layer up to the highest layer, meaning from layer 0 to layer 3 in principle. And they have done a lot of studying and testing, but they have in principle never really come up with a blueprint for an architectural proposal for how should the network be built, what type of technology should be used. And many of our stakeholders have during the years asked if we could come up with some ideas, come up with some kind of blueprinting. And what we decided was that we wanted to kick off a workshop like this where we will take up the different technologies, and we would also like to invite what we see as a good relation to vendors. We have invited Sienna, we have invited Infinera, and we have invited Alcatel-Lucent. And that's because we have established good relations with these vendors when it comes to testing equipment and technologies. It's also important here to say that when we started our testing, we also made it clear to the vendors that this was not a benchmarking exercise. It was a process where we wanted to investigate technologies, not to benchmark individual vendors among each other. So that has been a very strong foothold for us to tell that to the suppliers, and that will also be what will be the case when we are moving into to SHAN+ as well. So we are not trying to benchmark vendors, and we are hoping that we can give ideas and feedback back to vendors, which they can use hopefully in parts of their roadmaps or their strategy. So that was, I would say, I'm hoping that this is the Alcatel-Lucent leaving that's arriving, so I think we are more or less there. So that was the introduction to this workshop. I guess you have been through the entire agenda. You talked about the use case stories briefly. The aim of these use cases that we're going to do tomorrow is in principle to get your feedback, your ideas, how you see how we could build the future network architectures. And eventually Alberto and his team will pick up that these presentation and create hopefully a nice white paper referring to all of you being a part of this. Secondly, I will also say that there is not a hidden agenda behind this, but we will of course take this workshop and this white paper and use it as a part of the stepping stone for SHAN+ network architecture for Horizon 2020. I think that was more or less as of an introduction. Now I would like to go into, you said I had only 20 minutes left?
No, you
yeah. Something. Run quickly through this presentation. So it might be a little confusing that I'm referring to Joint Research Activity 1, but just bear in mind that this is under the GN3 umbrella, so to say, right now. And when I'm moving into the SHAN+ story, it's still called day1, but with another title. So, what was the aim for and background for in the beginning? Well, that was in principle to study and test and do some kind of prototyping when it comes to different types of technology. The prototyping part are more related to one of the other tasks, the virtualization part. But in order to test and study technologies, well, we had to get in clinch with vendors. I mentioned some of them here, but there's lots of other vendors here. And we have to establish good relations with all of them. And as I said, it was not a benchmarking exercise. It was just a way to test technologies in the best manner possible. So we are arranged for several meetings, and we established good collaboration. And all this, in principle, went into what I would call the day1 crunching machine. So they have been studying the technologies in the beginning and then prepared for different types of tests in order to support their findings. And the results should, in principle, go into some of the other activities under the shared umbrella. SA1 was, in principle, about updating the shared network. SA2 were more about bandwidth on demand tools, different types of networking tools. JRA2, also a joint research activity, were around the development of bandwidth on demand solutions. Some of you might have heard about Autobahn, and that's where that's hosted. Of course, we should also give feedback to the R&E community in general. Lots of everyone have been updating their network during the recent years, and we have given feedback, and stuff of this has been used by those enrons in order to figure out which direction they should take. Of course, all this have resulted in lots of paper. I think I currently counted around 600 pages. Of course, that's a lot of paper, and it's just paper and words, but it's really good quality, and there's a lot of good studies in these reports. Really good material. Of course, also spread the news, spread the information, spread what they have gained of knowledge at various conferences and other places, creating white papers and such. This one, I also mentioned that, well, we would also, as I said, like to give feedback to the vendors when doing testing. So it's not just something that we should benefit from, it should also be something that the vendors could benefit from, and we still see that as the case, that we are trying to get valuable feedback to the vendors which they can use for something, not just you lending us equipment and then okay, fine, but we are trying really to be objective here. Of course, finally, have a outlook towards the future. How should the future in principle look like when it comes to networking and network architectures? So just a quick overview of day1. The original work was scheduled to end April 2012, meaning it should then have been running for 3 years, but due to the nature of what I would call research, new things appears, and it has given us the possibility to come up with new things that should be tested and investigated, and that meant that we were able to extend day1 into April 2013 to the end of the GN3 project. There were, or still are, 16 partners. You might be familiar with most of them. I won't mention them all here. There were 3 subcontractors. Here it's mentioned as University of Essex. They had just recently moved to Bristol, so now it's University of Bristol. They took their entire optical department and moved down to Bristol. It gave them more opportunities and in principle also funding. I2CAT from Spain and Danish Technical University has also been a subcontractor in this. So in total, 55 participants under day1, and for the 3rd year, last year, we were allocated what is equal to 138 man-months. It has been more or less the same year, the 1st year, 2nd year, and 3rd and 4th year. So there has been going a lot of resources into day1. Now I'm starting out with Alberto's task. You are familiar with Alberto. Alberto, he's the task leader for task 1, which is called Carrier Class Transport Network Technologies. So their primary aim here was to, in the beginning, to plan and coordinate what they should study and test, and that was done. As I mentioned in the beginning, it was difficult to, I would say it was around 2008, 2009, a financial crisis. It was a little difficult to get equipment out of vendors, I would say, due to the financial crisis, but I think it was also, it is still costly equipment to get out for a period. So, but I would still say we managed to do so, and I would still like to pay my thanks to the different vendors that have been so willing to participate in this. Of course, set up collaboration agreements. A big part which took place, especially last year, was building testbed and also visiting vendors around the world, I would say, visiting the vendor labs in order to do different types of testing of different types of technologies. So that has also been done. Of course, document things and spread the news at various conferences, etc. So, just taking a look, now I'm stepping back to the status of the second year. So, task 1, it identified these technologies as, I'll not say you could say the dominant carrier class transport network technologies. So Ethernet over MPLS, Ethernet, MPLS, TP, OTN, GMPLS for the control plane part, and next generation router networks. And then there is something about cross activity, and that was some of the parts that Victor mentioned, where we have done a lot of work together with other activities as well. So you could always argue if these are the most dominant technologies when we are looking at layer 2, 2.5, and 3. During the second year, they managed to come to a standstill where they were starting up the testing phase. And during the third year, they managed, in principle, to complete everything. And that was really good, especially when having to present stuff like this to the commission. Then it's really nice to say, well, we did it, and objective completed. So they were happy. As I also said, this some of the achievements. So again, they managed, or they presented at the Nordnet conference in 2011, and they did the same in the recent Nordnet conference in 2012 in Oslo. Created white papers, several white papers. Can't recall any. Is it 3, 4?
Yeah,
yeah, something like that. Some of the work highlights, as I said, extensive testing during the third year, a lot of collaboration with JRA2. The reason why I'm highlighting this is that typical when we have activities running, it's people have their work plans, and starting what's called cross activity is something that's beside the activity, and it's difficult to establish that if it hadn't been planned from the beginning. So this just shows you that it is possible with dedicated people, and I would say that the people that are on board in day1 has been really dedicated to the work and enthusiastic about their work. So that's really good. Of course, publication of their final deliverable was done was in April this year, and of course preparation for the fourth year extensions, which I will dive into here. So some of the extensions they have decided to carry on with was Ethernet over MPLS, Ethernet OAM features, MPLS TP, and OTN. So that was extension of the current, should we call it, subtask within the task. But besides that, we decided to add new subtasks to Alberto's task. So Ethernet over ORM and service assurance part. Open flow technology investigation. I know that Johan will come and tell you a lot about that later. I think it's tomorrow. According to the agenda, that's correct. And time-sensitive data transport. That is something that's led by, where is he sitting? There, Henrik Wessing, which we brought up because there has been a lot of discussion about which technology is best suited for time-sensitive data transport. And everyone had an idea, and everyone had a meaning about it, and when you just said, okay, let's try test stuff. Let's try this different technology. So that's some of the things that Henrik will present to you tomorrow. Some of the results. It's still ongoing task. Moving into the second task led by Lars Lange, Bjørn, photonic switching and experimental photonic facilities. Also been running, and now I can see Red Roland is sitting there, slipped out of SurfNet and went to Siena. So he was also a part of this. But photonic technologies in general, looking into new stuff, looking into new things. So they have been studying a lot of aspects there. Alien wave, and there is a special where especially Lars and Roland have been very, very active, running different types of alien wave trials in a multi-domain scenario. Some might say, why multi-domain? Well, we work together, all the entrants, so we are not competitors, so we would like to be able to shoot with photonics through different types of systems. So that's the reason why we have been so eager to test and to figure out if it's relevant and it's possible to operate alien waves in a decent manner. Of course, beyond 100 gig is commodity today. Most of you will say, I guess all the vendors here will just nod, yes, it's commodity. We are looking into 200 gig and 400 gig and terabit solutions. So of course we have to follow and track that as well. And if possible, be part of different trials in order to show that is something that we are focusing on as well. And finally, of course, control plane matters. Control plane matters. Yes, the reason why we are also looking into that is that what we have seen during the last couple of years is the integration of the optical part with the digital part. Here I'm talking about the OTN switching functionality that has been incorporated into many optical systems. And in order to have much more flexibility, it's also needed to have a decent working control plane solution where you again can move that up towards different types of bandwidth on demand solutions that can control things or provision things. Some of the achievements, there was SessionNet and Arconet set up this photonic service which were operated between Prague and Vienna. And I guess Jan, you are going to tell, is that today or tomorrow?
Today.
It's today you are going to tell something about this trial. As I also mentioned, the alien wave story was used jointly by Enron, and here in this case, SurfNet, Nordion, and Siena did a couple of trials. So the first one was a creation of a 40 gig link going from Geneva to CERN and then back again to Amsterdam. This was running on the on SurfNet Siena equipment, so that was what I would call a native system with a native wave. But the connection from Amsterdam to, in principle, from Hamburg to Copenhagen was running in the Alcatel-Lucent system, meaning as an alien wave in this scenario. So we were able to set up a link where I think it's 1600 kilometers were the native part on a 40 gig link, and it was presented during was that Torino conference in not in Reykjavik, no. Last year again. I forgot the place, but yeah, where it was presented. Sorry.
It was in Prague.
And was it in Prague?
Torino was in Prague. Yeah.
Was it in Prague? Yeah, it was in Prague.
This year is in Iceland.
Yeah, yes, this year it was in Reykjavik. Yeah, and next year it's in
Amsterdam.
no, in Maastricht. Yeah. No, never mind. For the Torino conference in Reykjavik, Sienna came and said, well, we would like to do an alien wave from, if possible, on a sea cable. And we managed to give you contacts to Danice and Farice in order to set up a 100 gig wave going from Blåvand to Reykjavik as an alien wave, and then using the link from Blåvand to Copenhagen and then down to Amsterdam in order to hook up UVA in order to show a video, I think it was 4K demonstration running on this link, and it was quite impressive. And I will also say that Sienna thought it was coming up, yeah, quite impressive. So they launched this press release saying that they had demonstrated this together with I think they say leading INRAN's, world's leading research institution. Yeah, impressive. Yeah. No, just joking. The important thing here is that as INRAN's, we are looking for network transparency. It's important to support the INRAN way of networking, and we will keep on chasing these things and be eager to participate in trials around things like that. Some of the achievements, I'll run quickly through this. Some of the task members from these tasks have been acting as, I would call it more or less consultants for in principle when we are talking about the SHANT upgrade. So Nordinet, GRNet and SESNet had given technical experts to Dante in this case to help in the procurement phase, and the same for Janet UK for their UK upgrade. Nordinet were helping them with their procurement process. Another thing they have been very focused on is of course power consumption of optical system has been evaluated, and that's related of course to the Green Touch initiative. So that's also been parts that have been discussed and evaluated and studied. Some of the year 4 plans continue on the alien wave story, especially trying out alien wave on the updated SHANT network. See what's possible, see what it will take. So investigate and testing, increase focus on the operational aspects. Photonic services, dive more into that. Feasibility study, reach and technical challenges are something that has to be studied. As I also mentioned, 100 gig is legacy. Next step is 400 gig and terabit solution. So understand new modulation formats, investigate the technologies around, and of course, if possible, be a part of some kind of lab testing or field testing. How much do I have left? Nothing? Okay. Then I'll do this very quick. Now moving into GN3 Plus, which is going to start April 2013. Network Architecture for Horizon 2020. So task 1, Future Network Architectures. The reason why I put this umbrella is because I see task 1 as the umbrella or the parent task for the remaining 3 tasks, because their results will be fed into task 1, which will come up with a generic architecture approach. Task number 2 is network architecture for cloud services, and the third one is about aggregating high-speed mobile networking. And the fourth task is a task we have decided to call single and multi-domain networking. It's a task that are framing several other subtasks which are going into what's being called open calls. It's mostly related to photonic matters, but there is also something around clean slate architecture approach. Should I stop? Because now I'm just going to go more into details about the different tasks. You're a timekeeper. How much can I have?
5 minutes.
5 minutes, okay, and then I'll do it very quickly. And then I'll just quickly say those tasks here are also referring in principle to the case studies. So as I said, there was a small hidden agenda behind things. So cloud-based services can be seen as three independent structures. So what this task is going to look at is the access network which connects users to the application. Of course, also the part that where you have extreme high-speed networks which interconnect virtual machines that also have to come into play and to be studied. And megapipe networks interconnecting storage tiers. So this task will investigate and come up with a solution and propose solution for an architecture that can support cloud service in the best way possible, and also come up with but also do a demonstration of their findings as well in order to support their findings. The third one is a spring off of some of the studies that are already taking place in Gen3, where all of you might, or some of you might not, have heard about eduroam. The thing here is that if we can spread eduroam out to the public, especially to hotspot, make agreements with commercial operators in some places, meaning that we would like to bring out the network closer to these hotspots, meaning that we now would have to look into how should we build aggregation networks. Today it's typical big core networks that are spreading out to campuses and to major locations, but we don't have this fine granularity of fine connectivity into the public area. I know that many will just say, well, isn't it just what the traditional telcos are doing? Couldn't you just copy that? Yeah, probably we could, but we would like to do the study of that. How could we build an architecture that could support this? Not necessarily become a parallel thing to the traditional telcos. So this is the idea behind this. I'll just skip this part. Task number 4 is single and multi-domain network research. It might look a little strange that this has come in, but it was due to the fact that we had to merge two activities here, more or less quarter past midnight, where we had to finalize this stuff. So this is in principle the old activity when we tried to flesh this out, which were focusing on optical matters. So this has been put into one task now, but it's been running as what is called open calls. So it's in principle an open tender process where everyone can go in and bid for this. It can be third parties, it can even be the private sector that can go in and bid for this, saying that we want to do this and give you the result. So the first one is about research into clean slate architecture, a concept that in principle involves rethinking of the fundamentals. The principle here is, can we just keep up climbing the ladder for interfaces sizes, meaning 100 gig, 200 gig, 400 gig, terabit solutions, and then just continue? Can we continue on that path? We have done this for the last 30 years. Can we still continue on this path? Or should we do something completely different? So this is the thinking behind the first task. Second task is around investigation and tracking of the development of flexible optical networks. So that's also something that has to be studied, and and investigate it, and even if possible be a part of some of the things that are going on in the industry. Number 3 and number 4 is something that's coming together. The first one is a modeling tool that we're just seeing that it's needed if we want to do something about the operational aspect of photonic services and alien waves. So we need to come up with a modeling tool. I know that all vendors, you have your own, or they have their own modeling tool for their own equipment in order to design and plan a rollout, for instance. But looking into a multi-domain scenario, it's a different matter. So it might be an interesting thing to look into. And then of course, testing alien waves over the SHAN network on the upgraded system that has just recently been deployed. Finally, the umbrella task, as I mentioned, just quickly put in the yes. So this task will pick up on what is being done in the network architecture part for cloud services. The aggregation of high-speed mobile traffic will be taken up there as well. But they will also look into video processing. What is the best match and fit when it comes to technology? Higher rate services. This is more or less looking into the clean slate part. Lower latency. I could also see time sensitive data transport. And then of course new emerging application that might be identified during the next couple of years. We also have to take that into account. So at the end of SHAN Plus, we should hopefully be able to present a couple of proposals that can pave the way for NRENs when they are designing and planning for upgrading their networks. So that's the idea with day1 on the SHAN Plus. I think that was it. Just quickly check. Yep, that was it. Yes, questions?
Regarding task 4, do you run any open tender process? Who can apply? How you can apply? When you can read about this process? How do you send information? So
all these questions have not been resolved yet. Sorry. The worst case scenario could be that the tender process starts 1st of April and we are able to sign something 8-9 months later, and then they can work for 12 months. It's not a good solution. It's something that has been put on our shoulders by the Commission. And for this short duration, the SHAN Plus, we can always argue if this is the right way to do things, but this is how things are. We cannot change it. We are, although, hoping that we can start the tender process, in principle now, more or less, but start up the process as fast as possible and hopefully launch the material January, February. But nothing is certain. Nothing has been decided yet. Okay. People are working on how to handle this.
But as I understood, a rank can't...
Well, who can apply? That has also been discussed, and in the beginning it was, in principle, only third parties, not NRENs. But now it seems that NRENs might be able to apply for this, and then you would ask the question, why then do the open calls? And my answer to this is, yes, Commission, ask them. But it seems that everyone can apply for it.
Okay.
So there is, yeah. I think the reason why they wanted to have this in force was to secure that we were working together with universities and the industry better. But as I already presented here, we are already working together with universities and the industry around things. And this is just complicating things. It's a lot of paperwork, it's a lot of bureaucracy that are put on to everyone's shoulder to run this. So, yeah. Sorry, but this is how things are. Any other questions? No? Good. Good.
Okay.
Thank you.
So we have a break now. And we start again. I know the agenda says 11, but we start 11:15 because we have actually two presentations that are sharing the same slot. If we then finish before, then we have more time for lunch. But I think it's better we start 11:15 then. Okay?
Okay. I don't think that's what he meant.
Does you?
Yeah.
Understood.